Now, keeping in mind all these things, that epsilon ijk, if it will be cyclic means clockwise, then it will be +1. If indices will be repeated, then it will be 0. And for acyclic or anticlockwise, we will have -1. The total number of components are 27, and out of the 27, 21 components are 0, 3 components are 1, and 3 are -1. Similarly, if we will have a Kronecker delta such that the last in one and the first in the other index will be the same, then we can skip this one and do summation on the first and the last. The result will be the same. And if we will have two Levi-Civita tensors and all the indices are the same, then the result will be 6. And if one of the index is the same, then it will be equal to this. Similarly, if the indices of A and B vectors, AI, BI, they're the same, it means it will be a dot product. So keeping in view all this information, now I will go to the cross product, and for cross product we will use the Levi-Civita tensor. So if we are having vector A cross vector B, we know that how to evaluate this one. We can evaluate this one in component form and a matrix form, but in Levi-Civita tensor we will write this thing is epsilon ijk, where this is the different indices, 3 indices, and then this is the first component, like the first index will come with the direction, and then A, J, and B, K. This is the representation of the cross product in the form of Levi-Civita tensor. So AJ, BK, and EI, we can write this EI here as well, but we will prove this thing that the cross product can be written in this form. Notice, for example, I do some calculations here, like A cross B, when I write in the matrix form, then this is equal to, this is the x unit vector, this is the y unit vector, and this is the z unit vector, and then ax, bay, and az here, bx, by, and bz here. Let's say write the very first component of it, and the very first component of it is ay bz minus az by and x minus. Then for the y, I will write axbz minus azbx, and in the y direction plus, then we will have the z component axby minus aybx, and this is in the z component. So we are having x, y, and z components here. Now let's start. I calculate the ith component of it, or the x component of it. I can write this, keep in mind this one, that this is actually the I unit vector, this is the j unit vector, this is the k unit vector, or another representation. I can write this as E1, this is E2, and this is E3. So these are the different bases, different representations. Let's say I write now the ith component of this, A cross B. So the ith component, when I write the ith component, then this is the right representation. It will be the e ith component, and then we will have the epsilon ijk here. So it is epsilon ij in k, the summation will be on ij and j in k, and it is aj bk. And let me find out this thing. This is equal. Now I will write E1 here, the first component here. So this is E1. And then it is epsilon ijk. So I have taken already 1. It means for j the only possible value is 2, and for k the possible value is 3, because if I write 1 and then 1 here, so there is a repetition, it will be 0. 1 and 1 and 2 will be 0. 1, 2 and 2 will be 0. So the only possible value here, in order to avoid repetition, it will give 0 repetition. So here we will, this we have already selected from the component. And then 2 and 3 are the possible values, and then it is A2 and B3. Then plus, we are having the other possibility that if this one is 1, the other possibility is that this is 3 and this is 2. So 1, 3, 2 is the other possibility, and this is A3, B2. Now let's convert this one into, here I know that from that relation epsilon 1, 2, 3 is equal to plus 1, while epsilon 1, 3, 2 from here 1, 3, 2 is minus 1. So we got that the first component of it is equal to A2, means I will now write A2 is AY and BZ from here, means just converting them into the X and YZ here. Let me first write this one. This is E1, and then we are having A2 B3 minus A3 B2. And I can convert this one as AX, AY, BZ here minus AZ and BY here, because B2 here, and then it is in the X unit vector, because E1 is the X unit vector, and we got the first component. Similarly, I can write the other components. If it is A cross B vectors and I want to write the jth component, then how I will write this one? It will be equal to EJ, and then it will be, is I am writing J, so it will be JKI, means in this order. So it is epsilon J and K and I, epsilon JKI, and we are having the A, K and BI, because this is the J direction, J component, then K and I here. So I can expand this one, and it is equal to EJ component. And now look here, I will have epsilon, so J I have written that this is equal to 1 here. Let's write this, we write this as 2, as this is the second component. So we will have 2 here. Then the other possibility is that we have 3, 1, and then A, 3 and B, 1, plus we have epsilon 2 here, and then the other two components will be 1 and 3. 1 and 3 and A1, B3 here. So expand this one. This is equal to E2, and epsilon 231 is equal to plus 1, so we have A3B1 minus, this one is 213 is minus 1, so we are having minus A1B3. Let's convert this into the x and y. So I will write this is minus, let's take minus as common, so this is minus and ax bz here minus az and bx, and it is in the E2, so this is in the y direction. So we are having minus ax bz and az bx in the y direction, and so on. Similarly, we can prove the third component, and the third component is a cross b, and this is the kth component. So we will have, this is epsilon and k will be the first. So when this is k, so we will have the next is I and j, and this is will be ek and ai b j components. So let's expand this one. We will have e and k is 3, so this is E3, and now expand this one, epsilon 3, then we have 3, and the one possibility is 1 2, epsilon 1 and 2, and a, it doesn't matter if we write 2 1 first, so it doesn't matter, the terms will be the same, and this is a and 1 and b is 2, and then plus epsilon 3, and then 2 1 I can write, here is 1 2, so I can write 2 1, and a 2 and b is 1, and I can now convert this one. I know that this term is equal to plus 1 and this term is equal to minus 1, so E3 equals, here this is a1 b2 minus a2 b1, and I can write this in the xy form is ax by minus ay bx in the z direction, and it is ax by and minus ay bxz. So I have proved that the cross product can be written like this, and this was one of the example of the cross product, that we can write cross product like this. Now let me show a scalar triple product. But before going to scalar triple product, keep in mind one thing. It is sufficient we prove only one component of it, whether it is the I, j or k component. We only prove one component, and then it is evident that rest of the component are true as well. So we now consider another example. This was our example 1. And now we consider example 2. Now example 2 that we consider is of scalar triple product. Let's say I write U or A cross B cross this. Let's say write A dot B cross C. Now I will have to convert this one into the product form of the Levi-Civita tensor. So let's see here. If I consider the ith component, then it means the B cross C will also have its ith component, because this is the dot product, and for the dot product we have said that 2 will be the same component, it's an inner product. So this will be B cross C, and this B cross C will also be the ith component. I will have to write this in a vector form. This one is in the index form. Now B cross C, I know that this is the ith component, so I can write this one is AI, and then I can write epsilon naught, epsilon mean the Levi-Civita tensor, and this is the ith component, so I have written I and J K, and to B and C I will give index J and K, B, J and C, K. So this is our result, and now I can write this one is, if I just move it here, epsilon I J K, and U, this one is, let's say I can write this one like this as well. There is no problem in this. Epsilon I J K, and this one is AI, BJ and CK. So there is no harm in writing it like that. And now I can change the indices. And the indices, let's say I change, as I know that epsilon IJK, I know that if I keep the order the same, like IJK is equal to KIJ, this is cyclic, IJK, KIJ, so they are all equal to 1, so I can just change this one and I can write that this can be written as epsilon KIJ. When I write this as epsilon KIJ, then AI, BJ and CK, AI, BJ and CK. Now if I move this I and J here, so I can move this CK here, and then epsilon K here, and AI, BJ. So what does it mean? It means that this is CK, while this one, this is epsilon KIJ, while this one epsilon KIJ, I can write this as, this is I and J component. It means this is the A cross B kth component, because this is A cross B and this is the kth component, epsilon K. So here CK and this is the kth component, it means it is the dot product of the two. So I can write that it is actually C dot A cross B. And we know this thing. A dot B cross C can be written as C dot A cross B. As long as we are cyclic, we can do this thing. So very easily we have proved that this can be written as C dot A cross B. Similarly, if I write this thing like this, that I have written this one AI and this is the ith component. Let me come over here again to this relation, and this is epsilon IJK, this is epsilon IJK, and AIBJ, AIBJ and CK. And now I just write this one is BJ here, and then I write epsilon, this is if I write it is JKI, so JKI, it's cyclic, it's also equal to 1. So JKI, I can do this thing. Then it will be the AICK. AI means K is earlier, so I will write this first, and this is CK and AI. And now I can see this one, that this is actually BJ, this is BJ, and this one is C cross A. So this is C cross A, and we are having the jth component of this, because this is Ki, this is Ki in the jth component, and finally I can write this one is equal to B dot C cross A. So this means that we have very easily proved that A dot B cross C is equal to C dot A cross B, and is also equal to B dot C cross A. This is the vector triple product. It is the same thing. B cross A dot B cross C, then C dot A cross B, and then B dot C cross A. So they are cyclic permutations, they are cyclic in order, and with the help of Levi-Civita tensor, we have proved these identities very quickly here.